Okay, so now we're going to work on the Sagittarius symbol. This is video 194, and it's Thursday. Let's make sure that's true. Yes, it's Thursday, March 18th, 2021. The last video was 193 according to my list, so yes, we are on video 194. Okay, just want to make sure that's correct because I don't want the wrong number to be on my stream and then be an hour into this and then realize that I have the wrong serial number. Okay. So the first thing we're going to do is we're going to go into the main cutting file thing here, and we're just going to steal all this code that says Scorpio code, right? And we're just going to cut and paste it, and we're going to rename this to the next symbol we're working on. So Sagittarius, which I can't spell, so Sagittarius code. And it's a good thing we have cut and paste because I don't want to have to spell that again. So over here, Sagittarius. And then for the shorthand functions, right, this is just going to be Sag, right, the first three letters. And then over here where we have Scorpio, anywhere we see Scorpio, we're going to change it with Sagittarius. So Sagittarius. So I just want to make absolutely sure that I'm spelling this correctly because it's going to be really annoying if I see like errors that say a certain function doesn't exist. And I'm like, what do you mean? I'm calling it right there. And it turns out that the reason that the compiler is complaining is because I'm not spelling things correctly. That always makes things really difficult because you're looking and you're trying to find the problem and you don't see the problem, and then the compiler is telling you that there's a problem, but then you look at the code and you're like, there's no problem, it's right there. And it's because you didn't spell it correctly, right? Because the compiler is not going to tell you that you have a typo, right? Okay, so now that that's in there, we can open up one of these, right? And we can stub that in as well. So we're going to stub in kind of this, right? So this is going to be the Sagittarius, so SAG. And then we'll save this as, in the cutting folder, right? We'll save this as SAG001.scat, right? And then we'll copy this. And this is just so once we're done, we'll have these files that have the exact same name as the function being called, and it's going to make it easier to connect the SVG that was rendered to the actual code that was responsible for rendering that SVG. So SAG1 calls SAG1, SAG02 calls SAG02, and so these are the .scad files, and then later we're going to have a .svg file with the exact same name, right? Just we want to make the code very easy to follow later, right? Okay, so now that we have that in place, the next thing is hope that we haven't introduced any horrible syntax errors, right? We probably should have done this earlier, but we're going to open up the main file. We're going to do F4 to refresh, and then we're going to just, no geometry to render, that's fine. No syntax errors, though. So within here, we want to go and create another section, right? So we had Scorpio code, and the next thing we want to work on is Sagittarius code. So we're going to name it Sagittarius code, right? So we just want a consistent pattern in our file. So we've just been calling it, you know, symbol name underscore code, right? And so this is all the code for figuring out the design of this symbol is going to go in this section divider. And then we're going to name it consistently here as well. So Xocom Sagittarius, okay? Takes this SVC object, which is for shopbot constants. Okay, so then right here, we're going to call it Zot SBC. We're going to call it so we have something to look at as we're working on it, and then we're going to turn on this debug. Okay. Okay, cool. So I thought I was going to say something, but I forgot what I was going to say. Oh, too late. Oh, so the problem with like C code and also OpenSCAD code and a lot of code that is not as object-oriented is that it's still really good code. It's still a really good programming language. It's just that some of your more powerful programming languages take a lot of discipline to write good code because it doesn't hold your hand. So there's a lot of discipline here because I have to, there's no formal namespace here, so I have to have the discipline to namespace things correctly, right? And if I don't have that discipline, then I'm going to be in trouble, right? Okay, so now that we have this here, we need to just figure out some basic shapes here. So we're thinking that for the Sagittarius, it looks like kind of like a 45-degree angle, arrowy thingy. But we might want to just look that up for a second and just say Sagittarius symbol, right? So we might want to look at Sagittarius symbols on the internet to see what kind of variations are there, right? Because, okay, so we can have like a little, it's a bow, right? Okay, so I get it because it's an arrow and a bow. So having that line be curved kind of makes sense. Now, it's not curved everywhere. Now, the curve could be because people thought it was a bow, so this is actually a stylization, not a more correct version. Like, this might be the most correct version of the symbol. Holy crap, what is this? I've never seen this. Is this some type of weird, like, alternate supreme zodiac? Astrology alphabet. Interesting, interesting. So these are different than what I'm used to looking at. Oh, these are like the other, the less common. First of all, I don't know much about astrology. But yeah, there are like, there's more than just these basic symbols that I'm looking at, I think. Like, there's a whole bunch of really complicated symbols. But we're just going to go with the least common denominator, because you know what? In this case, I am the least common denominator. I don't know that much about astrology. So we're just going to go with what's the most recognizable. So, oh, this is kind of cool. But yeah, it looks like we can get away with just, it's just a 45-degree line with this arrow thingy, right? So let's do that. Now, do we want to make it, do we just want to draw it not rotated and then rotate it into place when we're done? Would that be the easiest way to go? Then these lines could be, we could rotate this 45 after we draw it, and this line could then be a 45. Yeah, so I think that's what we're going to do. We're going to draw it. So yeah, just taking a little bit of time. Just taking a little bit of time to think about what the heck we're about to do. Will save us a lot of time in terms of writing this code. So let's go, let's put a breakpoint here. Actually, Control Alt Shift F2, that's a shortcut I have to remove all breakpoints. We'll put these breakpoints back here. We have the debug turned on, so it looks like we just got to zoom out. Okay, there we go. So, yeah, let's just draw this in terms of, so first of all, let's think of some variables. So len equals, you know, zot, so let's go over here. And Sagittarius symbol const. So we want to name it kind of the same naming convention. And then within here, we're going to put some constants. So I see kind of like 3 possible, like if we want to think of the line lengths we want for everything, we could put them all here, right? So there's 3 variables we need, right? So we need zot, Sagittarius. God, I don't want to. I hate this. This is annoying. So, right, I already spelled it wrong, right? Sagittarius. This is why I say this is going to be annoying. So Sagittarius, and so this is going to be the major length, and I don't know what that needs to be. Maybe 3 inches. And then we have the perpendicular length. The perpendicular length. And then we also have perpendicular length, I don't know, 1. And then we have the arrowhead line lengths, right? So major axis length. Okay. This is the perpendicular len, right? And then over here is the arrow tips len, right? So there's only like 1, 2, 3 different lines. There's 4 lines in total, but they fit within these 3 categories, right? So we can take this here, right? We can take these constants and we can put them into here, right? And as we're putting them in here, I don't want to have to type that. First of all, this is very verbose, and second of all, it's a pain to type. So we're just going to say major, you know, blah, 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 len equals this thing, right? And then we can just shorten this, right? So we can say we can literally just take these here, right? So we can just take these like that. Bam, we have the constants we want to start working with, right? F4, make sure we didn't introduce any syntax errors. And then we're going to make it kind of aligned to the x-axis first, and then we'll rotate it after we're done. Or we could make it directly up and down. Directly up and down I like a little bit more, just because figuring out the top of the arrow would make more sense. So what we're going to do is we're going to make a vcarve inch pocket. So a pocket is a rectangular hole. And, well, it could be a pocket or it could be a line. Let's just use pocket. And we're going to do the thickness. So thickness needs to be put in here. So thickness, and that equals, let's go up. Well, actually, we've used this variable many times, so we can just steal it from somewhere else, right? And put it here. So this is the thickness variable we need. And just throw that in there. Okay, cool. So with this thickness, okay, I'm getting annoyed. Let's just align that. Okay, so with this thickness variable on the x, it's going to have the thickness. On the y, it's going to go up by the major length. So just say major length. And then the padding, there's not going to be any thickness padding, right? So it's just going to be, the area is going to be defined by x and y amount, and there's not going to be any extra overlap, right? Okay, so there, we got this thing. And, you know, we might want to make it a little bit bigger, but, yeah, we might want to make that just a little bit bigger. So let's go look at the major length for a second, and let's bump that up to, like, maybe a 4, right? So let's just try that out and see how that works. So F4. So, right, because this is going to determine how close it is to the edge, right? So 4, maybe 4.5 might actually be okay, right? Judging by how close we've been getting to with the other things. So 4.5, maybe even 4.8, we could probably get away with 4. Yeah, so 4.8 I think is pretty good. Right, we want to keep like about a 1/4 inch away. So these lines you're seeing about are 1/2 inch thick. So we want to keep a 1/4 inch away from the border. So I think that 4.8 is pretty good. Right, we're just eyeballing it, right? We're not trying to be precise here. And for the tip of the arrow is going to be kind of the hardest part, right? So to get this working, we need to go, we're going to go inch y, right? We want to go inch y, SBC, and we want to move up 0 plus the major length divided by 2, right? We want to get to right up to this tip here, right? So the major length and then divided by 2. And if we do that, then we can draw kind of a line segment from here and then down, right? So then we're going to make a vcarve inch line using SBC, using a certain thickness, and then using a point. We want an origin point, and then we want the left point, right? And then we want this thing, and we want a right point. And the origin point here, well, the origin is going to be relative to right here because this is where we've offset it to. So the origin is going to just equal 0, 0. And then the left point, we don't know yet. And then the right point, we don't know yet. We'll figure that out. For now, we can just put like a 0, 0 in here, right? Just to have it ready, have it stubbed in for when we're ready to do this stuff. And let's do F4, make sure we haven't introduced any syntax errors. We see we have a little dot right here. So we want to back up a little bit. So this origin that we have is not quite where we want it, right? We want this circle to back off the tip of the line. And in order to do that, we need to change what the y is. So we want to go back off by the radius of this thickness. So we want to just go 0 minus, and the thickness divided by 2 should be what we need here to get that into position. So go F4 again, and nope, we're still having some problems here. So let's think about this. Well, the left is still at 0, 0, right? So we want everything to be in relationship to the origin, right? So orig 0 plus, you know, some type of calculation. And then after we do that, we want to convert it to, actually, no, we don't have to convert it to anything. It's just good like that. Okay, so let's take this, and here's the x, here's the y, right? So the other points are going to be in relationship to that origin point. So F4. Okay, so now both of the points of the line are now kind of where I want it relatively now. And now the left, how are we going to do this? Well, we know that we want like this 45-degree line, so this is 270, and so we want to go 270 minus 45 and plus 45. So minus 45 to get over here, plus 45 to get over there, right? So when we're looking at this, we're going to go like cos of 270 plus 45. Well, this is the left side, so that's going to be minus 45. And then times some type of length, and it's going to be the head length, right? So the head length is what we're using for that. So this one is the sine, right? And so let's just give that a run and see if we didn't do anything stupid, right? So yeah, that's pretty good, but that line is kind of embedded in here, which is creating some problems for us. So we need to we're going to have to think about, we're going to have to just, the best way I think we could do this is we can just, we'll trim off this excess later. Let's just get this into place, right? This is pretty much what we want. And then over here, right, instead of minus 45, this is a plus 45, right? F4, and then we got this little arrow, right? And the arrow might not be the correct size, and then also what I don't like about this is with the lines that we've just rendered, I'm going to do a 0 to make the nubs, to get rid of the rounding. I don't want the rounding there. So F4, get rid of that rounding, right? So now that we've gotten rid of the rounding, I'm going to say this line is way too short. So the reason it's short is because of this head length, right? So if we look at the head length up here, we can just change those constants, right? So here's the Sagittarius constants, and we have this head length, and let's just change it to, let's just change both of these to 2, because I'm going to guess that if this is too short, the other one's too short, right? So that's almost a little bit too big. So I'm saying, you know, maybe that's okay for this, but maybe for here, the perpendicular could probably be 2, but this needs to be like maybe half of that, right? So something like that. Okay, so now let's put this into, let's do like 2.0. Let's try to fix that up a bit. Okay, so F4. Okay, so that looks a little bit more reasonable proportion-wise. It could be maybe a little bit longer, maybe not. Let's not worry about it too much right now, right? So then down here, we want to finish this up, right? So that line, this line right in the middle, is this pocket thing, right? So to clean this up, we're going to go difference, right? And we're going to take this, and we're going to say, you know, inch y, right, SBC, and we're going to take this major length, right? We're going to take this major length, and we're going to go, you know, 0 plus that major length divided by 2, right, which looks exactly like what we've already done down here, right? We might want to actually condense this so that way we can see, so that if we token highlight this equation, we'll get both of them in the exact same spot, right? So bam, right there, we can see them right there. So now we want to just say like just delete it somehow, right? So the easiest way to delete it would probably just make like a circle. So vcarve inch hole, right? SBC, and then we want like a radius, right? So the radius can just be the thickness should be enough to take care of that. And I don't know if I'm missing anything. It feels like it's missing something. But let's just give that a shot. F4. So that did get rid of it, but now we have this kind of problem right here where it's kind of like, yeah, you got rid of it, but now we have this little tip right here. So what we could do is we could just branch. We could either try to make this a sharp little tip, or we could we could put like a little box right here. We could figure out where that tip is, where those locations are. I don't know how we're gonna do that though. Well, we know we have the center of this, right? So we know we have the center of this, and if we go this way by half the thickness, this way by half the thickness, then we'll be at this tip right here. So we could do that. We could fill in the tip. Fill in arrow tip. So that's what we'll do. So right in here, we're going to create a section for that. And I think I know all the math we need to do this to fill in that arrow tip. So the arrow tip, well, here is the points, the left and right points, right? And they come from the origin. Well, hold on. Oh, the origin is right here. The origin is right here. So we just have to go half the thickness by 45 degrees. Half the thickness plus 45 plus 90. So first of all, we can just do it in here, right? So we can fill in that arrow tip. So right over here, we're going to put it in here because we want to be in the same, frame of reference, right? And in here, we're just going to say that, let's say T1, tip 1 equals, right? And this will be like a XY kind of thing. Tip 2 equals, or actually, we have the tip left. How do we do that? What order did we do before? Left and right? So tip left and tip right, right? So tip left, and this is tip right. Okay? And within here, we can, we want to figure out, this origin point right here is the org, right? This origin thing. So we know that we want to start off at that origin, right? So origin 0, and then plus some type of, well, let's just figure it out. It's cos, it's the cos of 45 degrees plus 90, right? And then it's times the thickness, right? Or the thickness divided by 2, right? Half the thickness of the line. And then for the, for this right here, it's the, want to start off at the Y location and sine, and then there we go. And then let's take this, put this over here. And for this, instead of 45 plus 90, it's 45 plus 0, right? Because there's no offset here, right? On the right, it's just 45, and then this is offsetted by 90 degrees. And so the left and right locations are now in place. So now all we have to do is draw here, here, and then at the original origin, and we'll get a fill, right? So we have a code for polygon somewhere here. So we're just going to do like polygon points equals, and then within the points, we have to also remember that the polygon takes native units, right? So as we're doing this, we have to be cognizant of that, to where when we do this, we have to go like TL times imperial converted to native, right? And then for TL times imperial to native, and we have to do this, so we have 0 and 1, right? So 0 and 1, and then let's copy paste this a few times. So we need 3 of these points, and within here, we want to go from the center to the right to the left. We want to go counterclockwise, right? So this thing is going to be org, right? So we're going to start off at the org, and then TL is in relationship to the origin, right? So yeah, so then TL, or TR, and then TL. And then we have this impnat thing. Now the question is, do we already have this defined in here? No, we don't. So what we're going to do is we're going to go steal it from somewhere else, because we already know we've been using it a lot. So go up here, take that, and then go back to the code. And here's the Sagittarius code. We're just going to put this conversion factor thing right here. So this means imperial to native, right? So it's a conversion factor that you take an imperial unit and you convert it to native units, right? So now, if we do this, this should all work unless we've screwed up our math somehow. So no, we didn't screw up our math. So it's kind of nubbed right there, but, you know, that doesn't look bad to me, right? That looks fine. In fact, I like the lack of sharp points because we're going to V-carve this, and sharp points are just not going to work out very well. And also, the other designs don't have very sharp, acute angles in the lines, right? So we don't want to break with the way we've been writing everything else, right? So now that we have this, we want to make a crossbar, right? So make crossbar. Right, so the crossbar, we'll figure that out, but let's just make a section for this. And then we'll be done. We're pretty close to done with this one. So in here, we want to find the pocket. So this kind of pocket thing. Let's throw this in here, and then let's just let's swap out the thickness. The thickness will be on the X, right? But it's not going to be the major length anymore. It's going to be that perpendicular length, right? So paste that there, and then go over here, F4. And so there, we got this thingy, and it's kind of like, it's a little bit in the center like that. I don't know if that's good. Like, I don't see anything where it's directly in the center like that. It does seem to be a little bit offset, which I don't know if I'm a fan of that, but that's, if you look at all the designs, it's not really in the center like that. We have some things that are a little bit longer, little things that are a little bit shorter, but I don't think that putting it in the center like that is exactly where it needs to go. It just doesn't look correct according to, like, all the astrological symbols that I can look up. Nothing really does that. Some of them do kind of, but I don't know. I think it's now I do like this line being somehow in obvious relationship to the center, so we could just move it by a little bit, right? We could try to like we could do like inch y SBC and do a 0 minus the thickness divided by 2, right? We could move it just a little bit and put it on tangent the bottom of the x-axis, right? And I think that's still gonna just look a little bit not good enough. Actually, that's pretty good. I just want an obvious relationship with the center of the circle, right? So let's take all this and say, let's just take all this and put it into a function, right? So we're going to take all this, and we're going to create another helper function. And I don't often break things up into other functions, but in terms of this, it's going to be easier. So non-rotated. So this is the non-rotated version, right? Because it needs to be rotated at like a 45-degree angle, according to kind of the reference that I've been looking at. So we'll paste that in there. We'll go F4. That should disappear. And then we'll go paste this back in here, right? And we'll give it the SBC value, but then we're going to give it a rotation, right? Rotate angle. The angle is going to be 45. The vector is going to be a Z up vector, right? Because we're going to, this is like a quaternion, right? So we're going to rotate it. You could think of this as a like a fulcrum, it's like a pen. It's like a axle in 3D space, or like you could think of it as it's like a nail oriented in 3D space. And then whatever you want to rotate, you just take a piece of paper and you pierce that piece of paper with that nail, right? And then you rotate the piece of paper that's been pierced with that nail to this degree here. So this defines a line oriented in any way in 3 dimensions, because it's quaternion, right? So it's just a 3-dimensional line, and that 3-dimensional line could represent that nail. You pierce a piece of paper, which that paper represents kind of the model you want to rotate, and then the amount of degrees you want to rotate around that nail you pierce the paper with, right? So let's give that a shot, because that might be all we need. That might be good, right? So our degrees are in the wrong direction. We want to go the other way. So negative 45 degrees. Go over here, F4. And I really like how it lines up pretty well with right here like that. I like that. In fact, I would like to maybe tweak that just a little bit to make it just hit that midline exactly. So what we could do is we could just add a little hack in here. So let's go find, so the arrow tips, that's the length for this. We're going to open this up a bit, and we're going to open it up a bit. We'll put the commentary over here still, right? So plus 0.001 maybe. I don't know exactly what it needs to be. Maybe 0.05, F4. Maybe 0.25. Doesn't need to be perfect. Oh. 0.08. Let's try something like that. F4. That's too much. 0.03 maybe? Okay. So, and then 0.02, how about that? F4. Oh, hey, that looks pretty good. Yeah, that's good enough, good enough, good enough. It looks good enough. Hack to tangent x-axis, right? So we just put a little hack in there to tangent the x-axis so we could get something that looks pretty good. But yeah, that looks good to me. I'm satisfied with this distance from the border, and we're good. That's what we want. So what we're going to do now is we're going to go down here, and we're going to remove this code we were using for development, right? F4. Then we're also going to undo this debug code once again, right? Clean up this file, close this, and now we're going to go into the cutting files that we have all ready for us. So the SAG files. So double-click this and just render it, and then zoom out, right? File, export as SVG. Change the extension to capital because I just like capitals. So that is the cutting file for the table design. And then let's close this and do the bottom of the table, which is the number 2. The reason we didn't name them bottom and top is because we're not certain about what these numbers are going to represent in the future. Right now, that's what they represent, but that could change as we get more elaborate with the design. So file, export as SVG, and so this is sag002.svg. So the sag002.scad file creates a sag.002.svg by calling sag002 function, right? And so the reason why they're all named exactly the same is so we can easily connect the dots between a file name with the image in it and where that code was generated from, right? That's the only reason we're doing it that way. So now let's do F4 here, refresh. Oh, not F4, my bad. F5, F4 to refresh in SCAD, F5 to refresh in Explorer. And the Sagittarius symbol, we want to take this and we want to screen clip it. So we're just going to screen clip this so we can have it in our little gallery. The gallery doesn't need to be professional looking, so we're not going to worry about cropping this nicely. It's just for our own personal reference, so that when we want to know what this is, we can just look at the gallery of all these symbols, right? So this is going to be Sagittarius. I cannot spell that word. Okay, so there, that's done. So now, going back over here, let's go look at what we have done so far, because we got some good stuff done here. Okay, so we got Aries, we got the Cancer, which is a crab, we got the Gemini, which is twins, Leo, lion, I don't know what Libra is. Oh, Libra is a scale. This is a bow and arrow, right? So this is Sagittarius. This was the Scorpio, which looks a lot like Virgo, right? Because the Virgo right here in Scorpio, very similar. This is a bull, and the bull is Taurus. Okay, so we got all these kind of things here. Cool. So that is what we need to do for here. So let's do a git bash here and commit what we have so far. And then what we're going to do is we're going to what are we going to do here? Well, first of all, we don't want to, for the next symbol, we want to have a unique stream for the next symbol. The next symbol is Capricorn, and from what I've looked at so far, Capricorn is out of Capricorn, Aquarius, and Pisces. That's going to be the hardest one. So, so I'm thinking 45 minutes for everything except for Capricorn might take double. So we'll say 4 hours max to get everything else done. So let's do cd ... cd ... and then git status. And why does this take so long now? I don't know why. I'm annoyed about this. So, holy crap, a lot of stuff in here. And we have Sagittarius, we have Scorpio, and Virgo. So, git status, git commit-am, done, and we have, so Libra, Scorpio, and Sagittarius. So those are all done, and I did not spell that correctly. Let's go over here, fix that. Okay, so that's my commit message, just telling, you know, what we just did, just a summary. And then we'll push this up to GitHub. We'll stop the stream. We'll start another one. I don't know if we're going to do the next stream right away. I think we should just do it right away. I would like to really just crank all this out and get it all done. So, I don't know why my GitHub thing is taking so long now. I think it's just that there's too many really small files in this. Okay, so git status. Okay, git commit. Oh god, I didn't add git add dot. I thought git commit git whatever. I thought git commit dash am would have added that. Oops. So my commit message sucks now because it didn't apply to what I actually did. This is infuriating. Why is this taking so long? Like we put this repo on a brand new thumb drive and git status. Okay, git commit dash am. Well, actually, let's just do up. Let's do the same exact message. For reals. Sure. I'm not going to go back and fix the original message. We just screwed that up. Git status. Okay. What the hell? Seriously, what the hell? Git status is taking this long? Why? Git push GitHub master. So git status does not have to reach out to the web, right? That's what you use a git fetch for. So I don't know what that is about, but there. We've done it. It took us way too long. It's like, take us, like, you know, that took us like 5 minutes to do. I swear to God. Like, okay. So anyways, that's done. Let's conclude this stream. So that was stream number 194. Yep, 194, and we just did the Sagittarius symbol. So we're good there. Let's stop the stream and start another one up.